We're going to talk about a horizontal shrink. Horizontal shrink. Horizontal shrinks look like this. Horizontal shrink, let's say by a third. We want to shrink this graph by a factor of 3. Now, a horizontal shrink would not be like a shift downwards like we talked about in the last video. We wouldn't shift it because when you do a horizontal shrink, you're going to be changing the shape. So any stretch or shrink is a shape change. Shape change. Shape change. Shape change. You're changing the shape. It's a shape change. Why do I care about the shape? It's a shape change. Change the shape. Change the world. Shape change. We're going to do a horizontal shrink by a third. The shape of this is going to change. It'll have the general overall idea, so it'll be very similar, but it won't be congruent anymore. It wouldn't overlay exactly on itself if we just shifted it. A horizontal shrink by a third would look something like this. You're going to shrink everything horizontally by a factor of 3, meaning that 3/8 is going to shrink to the point 1/8. All the inputs we're going to divide by 3. So 2/4 is going to divide to 2/3 4 would be. 1 and 2 is going to shrink to 1/3, 2. It's going to be really, notice how the point 0 though, 0, 1 is going to stay where it is. If we take a third of nothing, we get nothing. And so this point over here is the point -1 and then 1/2. And so that's also going to shrink. We're going to get the point, looks like here, this right here would be the point -1/3, 1/2. And we don't have to worry too much about the fractions. Everything's going to take care of itself if we focus on these here. So by the end of this, we are going to get a very steep exponential on the right, and it's going to still have that tail at the end. So it's going to be very, very steep. Now let's do the old point, new point game. Old point, new point. How'd you get that new point? Old point, new. Okay. So the point 0, 1 was on the graph, and so was the point 1, 0, 1 was on it. Let's go 1, 2, 3, 8. And we have some new points that we want it to become. In other words, we know that we want the point 3, 8. We want to be able to input the number 1 in to get an output of 8. This is horizontal. So none of the outputs are going to change. The inputs will. We want to be able to input the number 1/3 and get out a 2. So the old point, we could input a 1 and get out a 2. Remember, these were powers of 2. We want to be able to input 0 and get out a 1. Now check this out. If we're shrinking this, what's something we could do to 1? 1 to make it back into a 3. Could times it by 3. And we would do that because, check this out. We can now, this is the function here, we can now, if we input the number 1/3, this times 3 changes it back into what it was. And recall that this is the function 2 to the x. So these are the only inputs that output these numbers. So we need to be able to change all the inputs in a way so that it spits out these numbers here. Let's check the last point. That one was kind of awkward. We had the point 2, 4. And we said that we want to be able to input the number 2/3 and get out 4. But check that out. What number changes 2/3 back into 2? Or what operation changes 2/3 back into 2? Well, look, it's 2/3. So if you have 3 of them, you get back to 2. So notice what we're doing. We are multiplying all the inputs by a factor of 3. So the new function would look like this. You're multiplying all the inputs by a factor of 3. So if you want to do a horizontal shrink, you're going to have to multiply all the inputs by 3 because you now don't have to put as large numbers in to get back to the old. You can put small numbers in and it's still going to evaluate and give you the same outputs. Smaller numbers are going to give you the same outputs. And so it's going to shrink the graph because you can put in smaller numbers like 1/3, 2/3, 1, and you're still going to get the same output. You're getting 3 times as many outputs than the old one. So if you want to shrink it by a factor of 1/3, multiply your inputs by 3, because then your graph is going to be significantly more efficient. And the reciprocal is also true. If you want to do a horizontal stretch by, I don't know, if you want to do a horizontal stretch by 5, what you're going to want to do is make it so you have to put in larger numbers to get the same output. So if you want to stretch it out by 5, deflate your inputs, because then you're going to have to put in larger numbers. And when you put in larger numbers, you're going to get a much wider graph, because you're going to have to input larger numbers since you're going to be taking a fifth of them. If you take a fifth of all of your inputs, you're going to have to put 5 times bigger inputs to get the old graph. All right, so let's take a look at a vertical stretch by 3. Holy smokes, I don't think I have... no. Okay, a vertical stretch by 3. It's going to be massive. So, a vertical stretch by 3, that means if it's vertical, it's affecting the vertical axis. So the point 0, 1, if it's stretched out by a factor of 3, it's going to get stretched out to the point 0, 3. The point 1, 2 will get stretched out to the point 1, 2, 3, 4, 5, 6. The point 2, 4, if you're stretching that out by a factor of 3, it's going to go all the way up to 212. Off the charts. So it's going to be a huge, oh my goodness. It's going to increase much faster. Check this out. Your old point was 0, 1, you want it to be 0, 3. Old point was 1, 2, it needs to be 1, 6. Old point was 2, 4, you need it to be 2, 12. But if you notice here, all you have to do is multiply those outputs by 3. And since the output was constructed by 2 to the x, if you want to do a vertical stretch by a factor of 3, all you're going to have to do is multiply 2 to the x by 3. Because 2 to the x is the output. You're going to times that by 3. So you could write it like this, or equivalently, you could write it like this, and I think most commonly you're going to see it like that. This would be a vertical stretch by a factor of 3. Okay, so here's your practice for part 2 on transformations. I want you to describe all the transformations on 3 to the... Oh, God. Okay, I almost fell. I'm sitting on a yoga ball, and I straight up almost fell off the yoga ball. That would have been quite the vid. Would have had a lot of likes, a lot of comments. So here's your practice for part 2. You're going to describe the transformations on 3 to the power of x. So in words, you'll describe each of these, and be prepared to answer a few questions to do the reverse as well. But thanks for watching these quick videos, and I hope it'll help your practice. Bye!